Hi guys, this is Ms. Kurganin, and I am leading you through the 5 factors that affect climate for your note catcher. So there are 5 main reasons that a country's climate is the way that it is. And climate's different than weather. Weather is basically what you see out the window right now, but climate is over time. So are you hot usually over years and years? Are you cold usually years and years? That's more your climate. And overall on the planet, it's getting warmer. So when they talk about climate change, overall people's average temperatures are changing. But the first factor that affects a country's climate is where they are in reference to latitude. So if you are in the tropics, you're going to have a warmer climate, on average over the year than if you were up by the poles. So latitude and how high you are north or how low you are south is going to affect how much cooler you are. So the temperate zone where we live in, not too hot, not too cold. You're going to go back into your worksheet in a little bit and you're going to figure out if your UN country is in the Arctic, the temperate zone, or the tropics. And then you're also going to figure out which of the cities that are listed, which ones are warmest and which ones are coldest based on where they are in latitude. Because as latitude increases, the temperature decreases. So these coastal cities on your worksheet, you're going to put those in order. Okay, the next factor that affects country's climate is elevation. So here in Colorado, we are up high. We're a mile high is Denver's reputation. So as elevation increases, the annual temperature decreases. So we're on average a little cooler because we're up so high. If you were down lower, it would be on average warmer. Seems to make sense. So this is a wacky map. It doesn't actually make a lot of sense for me because the red is, I guess, the warmer part, and then the lighter color is a cooler part, but it's Alaska. So I'm just thinking like it's always cold, but they're trying to show like where is there variations in elevation affecting the temperature. This is a math problem. If you like math problems, you could actually figure out how cold it is up on top of a mountain because the temperature on average decreases every 1,000 feet. So it goes down 3 degrees every 1,000 feet. So if I'm at sea level and then I eventually go up to a mountain, every 1,000 feet that I climb, it's going to get colder. So there's actually a math problem that if you are good at math, you could try and figure out how cold it is on top of North Arapahoe Peak right now. And how do you figure that out? Well, you're going to be going up 2,000 feet. And so you are going to have 3.5 degrees colder. So that's going to happen twice. So it's going to be a little bit colder. And if you go down 3,000 feet, that's 3.5, 3.5, 3.5. So it's actually going to get warmer, 10.5 degrees. So you could wrap your head around that math problem down there. And I suppose that could be extra credit if you're really good at that. All right, proximity to landforms. The next factor that affects climate is how close you are to the mountains. Because if you look at this picture, notice how that cloud is getting stuck. It's getting stuck because there's a mountain in the way. I grew up in Seattle and the clouds got stuck. They couldn't get over the Cascade Range, and so it just rained in Seattle. So if you're on the rainy side, that's called the windward side, and it's cooler. It's moister because it's rainy. But on the other side, where the cloud couldn't get to, that is called the leeward side. It's warmer. It's drier. There's that adventure guy, Bear Grylls, who goes around and he licks trees. And he's licking the tree to figure out, is it on the cool side or the dry side? Because then he can figure out, am I on the side of the tree where the rain is coming from the ocean, or am I on the drier side where I'm on the other side of the mountain? So that's how he's figuring that out. Okay, so this is called the orographic effect. Oro, I think means mountain. Graphic is like writing. So it is the mountain effect. And it happens all along our west coast where like if you think of Portland's rainy, Seattle's rainy, those clouds can't get quite over the mountain unless they do. If they get up over the mountain and they get all like up there and high, then it comes down as snow. Yay, we love snow here in Colorado. So this is again looking at the rain shadow, the leeward side. Orographic effect. All right. I don't even want to look at this. We're going to skip this. Okay. So next is if you are close to the mountains, then you are going to probably get some of that moisture unless you're on the dry side. Now, Death Valley is like really, really low in elevation. So it is on the leeward side of the mountains. And there's one more picture here. I thought I was going to get to it on where does the weather travel in the opposite direction. And in the Gulf of Mexico, the winds kind of pick up from the Gulf of Mexico and actually head in towards Cancun or head in towards Costa Rica. So it actually is traveling west to east down there. All right, next is how close are you to water? So if you're close to an ocean, you're actually in a pretty sweet spot because oceans are like a heat sucker upper. So the ocean sucks up all the heat. If water and sucking it up is actually called moderating the temperature. And it makes the summers a little bit cooler and the winters a little bit warmer, which explains why all the old people moved down to Florida. But you are not looking at a climograph of an ocean city. What you're looking at there, that's called a climograph, and it's showing this is the temperature, and this is another, sorry. Here, excuse me. This is the temperature of an inland city, and you can see that it gets hot in the summer because these are all the months, and it's cold in the winter. And then this city, City B, is showing that it's by the ocean because it's pretty much blissful and fabulous all year long. So a climograph is something that you are going to use in your climate project that I'm going to talk about in a little bit. But inland locations, there's more of a change. Like here in Colorado, we're expecting winter to get pretty cold because we don't have an ocean near us. But if we were living like awesome, like down by LA or down by Laguna Beach, where my family's from, then you just have very little variation. It's pretty much awesome all the time. So here, these are climographs. Okay, so here's Iceland, and you can see that this is Iceland's rainfall and this is its temperature, and so it is by the ocean, but there's a little bit of variation right here. But oh my gosh, this is like huge variation. This is in Yakutsk, I don't even know if I said that right, Russia, and you can see that winters are going to be really cold, summers are going to be really hot. But what's going to melt your brain is what does a climograph look like if it, I'm trying to get to them, if you, where are they? If you are in the southern hemisphere, maybe they're not in this slideshow. Here, go back up. So if you're in the southern hemisphere, because the seasons are different, your climograph is actually going to be upside down. And what I mean from that is in Australia, their hottest months are actually in January and December. So if you ever saw the Wiggles, that's why Santa was always in board shorts. And then their cool months are actually here what we consider to the summer. So there are some epic pass, some ski passes that offer New Zealand as part of the package because you can still be skiing in the summer because their climograph is upside down. I wanted to share that to you, but I guess it's not in this PowerPoint. All right, so after proximity of bodies of water, then ocean currents. This is the last factor that affects your country's climate. So if you are by a warm current, then you have a warmer climate. If you're by a cold ocean current, you have a cooler climate. And the ocean is like a big washing machine. So think about warm air rises, cool air sinks. Well, the same with water. Warm water rises, cool water sinks. That up and down and up and down and up and down and up and down and up and down is what makes our currents. It's what makes our weather, and it's what kind of sends the ocean spinning all around. So there are some kind of notorious currents. This one's called the Gulf Stream. The Gulf Stream's known for being warm, and so this is what's bringing all of those sharks right now up along the East Coast that are eating people. Those sharks, which like the warm Gulf Stream, are coming up and then grabbing a snack right here by Massachusetts. So if you are a surfer or like to be in the ocean, you'll know that the California current that comes down around Southern California is actually a cold current. So if you are surfing, it's usually good that you wear a wetsuit. So there are warm currents, there's cold currents, and then that weather affects the countries that are near that ocean. All right. So there are going to be some questions in your worksheet that you're going to go back through, like this one, analyzing South America or Australia, which one's warmer, so you'll have to look closely at that map. And this is an exit ticket that you are going to complete on Schoology to prove that you watched this video. So you're going to look at your UN country and how far are you up in latitude? You don't have to get it exact, but tell me, are you in the polar zone, the temperate zone, the tropics? Then look at your topography, look at your elevation, and try and let me know, are you high in elevation? Are you low in elevation? Number 3, orographic effect. Do you have mountains in your country? If so, which cities are getting the rain? Which cities are dry? That's how you're going to answer number 3. Number 4, is your country trapped like inside a continent, or are you on the coast? And you're going to estimate, do you get a lot of rain, estimate your temperature, and you might have to do some Google search for that. Number 5, look at the ocean current map in this PowerPoint. Is your UN country near a warm or cold current? And it says turn into KG before class end, but you can also turn it into Mr. DiCarlo if you are in Mr. DiCarlo's class. Thanks for listening. Email if you have questions. Bye.